Tollens reagent is a chemical reagent used to determine the presence of an aldehyde or alpha-hydroxy ketone functional groups. The reagent consists of a solution of silver nitrate and ammonia. It was named after its discoverer, the German chemist Bernhard Tollens. A positive test with Tollens reagent is indicated by the precipitation of elemental silver, often producing a characteristic silver mirror on the inner surface of the reaction vessel. Laboratory preparation: this reagent is not commercially available due to its short shelf life. It must be freshly prepared in the laboratory. One common preparation involves two steps. First, a few drops of dilute sodium hydroxide are added to some aqueous silver nitrate. The O ions convert the silver-aqua complex form into silver oxide, Ag2O, which precipitate from the solution as a brown solid, 2-AgNO3 plus 2NaO Ag2O plus 2NaNO3 plus H2O. In the next step, sufficient aqueous ammonia is added to dissolve the brown silver, I, oxide. The resulting solution contains the Ag, NH3, 2, plus complexes in the mixture, which is the main component of Tollens reagent. Sodium hydroxide is reformed, Ag2O plus 4NH3 plus 2NaNO3 plus H2OA2, Ag, NH3, 2, NO3 plus 2NaO. Alternatively, aqueous ammonia can be added directly to silver nitrate solution. At first, ammonia will induce formation of solid silver oxide, but with additional ammonia, this solid precipitate dissolves to give a clear solution of diamine silver, I, complex 2, plus. Filtering the reagent before use helps to prevent false positive results. Uses Qualitative organic analysis once the presence of carbonyl group has been identified using 2,4-dinitrophenylhydrazine, Tollens reagent can be used to distinguish ketone versus aldehyde. Tollens reagent gives a negative test for most ketones, except those with alpha-hydroxy ketone. The test rests on the premise that aldehydes are more readily oxidized compared with ketones. This is due to the carbonyl containing carbon in aldehydes having an attached hydrogen. The diamine silver, I, complex in the mixture is an oxidizing agent and is the essential reactant in Tollens reagent. The test is generally carried out in a test tube in a warm water bath. In a positive test, the diamine silver, I, complex oxidizes the aldehyde to a carboxylate ion and in the process is reduced to elemental silver and aqueous ammonia. The elemental silver precipitates out of solution, occasionally onto the inner surface of the reaction vessel, giving a characteristic silver mirror. The carboxylate ion on acidification will give its corresponding carboxylic acid. The carboxylic acid is not directly formed in the first place as the reaction takes place under alkaline conditions. The ionic equations for the overall reaction are shown below. R refers to an alkyl group. 2, Ag, NH3, 2, plus LCHO plus H2OA2 Ag, S, plus 4NH3 plus LCO2H plus 2 hours plus. Tollens reagent can also be used to test for terminal alkanes. A white precipitate of the acetylide is formed in this case. Another test relies on reaction of the furfuryl with fluoroglucinol to produce a colored compound with high molar absorptivity. Both Tollens reagent and Fellings reagent also give positive results with formic acid, which is fully oxidized to water and carbon dioxide. Staining in anatomic pathology, ammoniacal silver nitrate is used in the Fontana-Masson stain, which is a silver stain technique used to detect melanin, argintophane and lipofuscin in tissue sections. Melanin and the other chromaffins reduce the silver nitrate to metallic silver. And silver mirroring Tollens reagent is also used to apply a silver mirror to glassware. For example, the inside of an insulated vacuum flask. The reducing agent is glucose for such applications. Clean glassware is required for a high-quality mirror. To increase the speed of deposition, the glass surface may be pre-treated with tin, chloride stabilized in hydrochloric acid solution. For applications requiring the highest optical quality such as in telescope mirrors, the use of tin, chloride is problematic, since it creates nanoscale roughness and reduces the reflectivity. Methods to produce telescope mirrors include additional additives to increase adhesion and film resilience, such as in Martin's method, which includes tartaric acid and ethanol. Safety: aged reagent can be destroyed with dilute acid to prevent the formation of the highly explosive silver nitride. See also, Brady's reagent, Benedict's reagent, Felling's solution, Walden reductor. References. External links: video of experimental process involving Tollens reagent on www.au.edu, University of Minnesota Organic Chemistry class demo result.